Hello guys, and welcome back to Joe's Ventures. And today we're doing another episode of our Jurassic World Evolution 2, not 3, mod spotlights, where we take a look at some of the wonderful mods people have been making and compare them to their real life fossil counterparts. So, as I mentioned, I've got probably a couple more pieces I want to do with this because there's a couple cool mods that are still coming out for Jurassic World Evolution 2. I will cover them. I'm not going to do the hard cut like I did with Jurassic World Evolution 1. Mainly because there wasn't that many mods, and I had thought about maybe going back and checking out a couple of those mods. If you guys want to see that, obviously I'll do it, but yeah, a lot of them, are kind of just samey by the same few people when I want to kind of move forward a bit, especially with 3. I think 3's modding is going to be incredible, so I'm quite excited to see how that will come out. But anyway, we've still got some really awesome mods coming out for Jurassic World Evolution 2. Jurassic World Evolution 3 has only been out for I think by the time this video comes out, maybe a couple weeks, if that. So yeah, I'm going to get quite excited stuck into this one. So we're going to be starting off today with Maxi-Dracon. So this is a mod done by Glitch. So let's have a look at Maxi-Dracon. So this is Maxi-Dracon, really cool species. Oh, and it does that. You gotta love it when it does that. Anyway, which one should we pick? I'll have a look at you. I like the colors on you. So this is Maxi-Dracon. So Maxi-Dracon is which means Mexican dragon. Is an extinct genus of ornithopod theropod, so it is related to things like Ornithomimus and Dinosaurs. It comes from the late Cretaceous Cerro de Pueblo formation of Coahuila, Mexico, and contains a single species, Maxi-Dracon longimanus, and is known for a partial skeleton. And it's actually the second known Ornithomimus known from this formation, following the Dinocheirid Paradoxosaurus in 2020. So the holotype itself was discovered in Chalo de Leon da Villa in 2014 in the Loma Padera Formation, a locality in the Cerro de Pueblo Formation, near the town of Poveno de Japala, going to butcher all these, in General Cedra Municipality in Coahuila, Mexico. And the skeleton itself is partly articulated, or partially articulated, containing a dorsal, sacral, and caudal vertebrae, severons, partial leg, left forelimb, with the humerus and metacarpals 1 to 3, partial pelvic girdles and partial hind limbs, complete left femur and tibia, partial right fibia, and it is actually pretty complete. So we do have a pretty good idea of what this guy may have looked like. In 2025, Sereno Banas et al. Described it as Maxi-Dracon longimanus, as a new species based on this, and the generic name is a Mexi, which means Mexico, and dragon is Greek for dragon, and the specific name longimanus basically means a long hand, so it's a long-handed Mexican dragon. So yeah, it tells you a little bit about it. So these guys, what made them unique is that they've got those very long metacarpals, and they hypothesized that these long hands may have been used to more effectively gather vegetation, similar to Dinocheirids and Therizinosaurs. Additionally, they have a slightly longer femur than tibia, which, along with the elongated hand, suggest limited cursoriality compared to other ornithomimosaurs, so not quite as good at running over open areas. They also noticed with Maxi-Dracon, with another specimen called Salamenlomimus, difference in habitat preferences. So based on the Salamenlomimus, it has a proportionally long tibia, broad feet and splayed toes that suggest cursorial locomotion over soft muddy surfaces. In comparison, the more slender foot is suggested for Maxi-Dracon, suggesting maybe ill-suited to traverse such terrain as effectively. So this guy may have been a little bit more of a forest animal, a little bit bigger, a little bit slower, not meant to be, not a distance runner like a lot of the other ornithomimids. So a little bit more, more similar to Therizinosaurs and Dinocheirids, maybe being larger herbivores. A good example, a little bit of convergent evolution. So it is, as I mentioned, Ornithomimosaur. It is believed to be quite really basal member of Ornithomiridae, so it is not related to Gladiomimus or Dinocheiris. Its closest relatives is Totolomimus and Cynorthomimus. So quite an interesting, actually, evolution. A great example of convergent evolution because you see there's a lot of similarities with Dinosaurs. So yeah, great example of convergent evolution. So yeah, we're gonna let you run off and do your thing. Good one, Glitch. Now next up, this is a mod that I've actually was asked to commission, but NetRaptor, I asked him if he was going to do it, but he said, no, I'll just put it up my priority list. So this was originally going to be a commission, but I'm really excited to be able to finally talk about the species we have got here, Jacopil. So this little guy's done by NetRaptor. Looks really, really amazing. So let's have a look at you. So this is Jacopil, which means shield bearer in Philochenon. I don't even know how you say that. These are a very interesting little guys. So these are a genus of basal thyreophorans, so the ancestors of things such as, that's a group that includes stegosaurs and ankylosaurs and their ancestors. So this is a basal member of that group, but it comes from the late Cretaceous for the Cinnamanian, so about 90 or so million years ago from Argentina, and its full name is Jacopil canicura. So the holotype itself, you can see it's a very interesting looking animal. The holotype is a partial skeleton that includes several osteoderms and a complete lower jaw, which was found on land owned by the Beryllian family in 2012 and excavated between 2014 and 2019-2020. The finds were prepared by Al Pazzo and J. Cazula, and the generic name Jacopil is the Pelican word for shield bearer, and this is the literal meaning for the clade name Thyreophora. So that's basically a translation. So Thyreophoran in Greek means shield bearer, so they kind of just put that and made it in the local language of in Argentina. And the specific name Canicura means crest stone, and Mapudurian, which is actually a reference to its uniquely deep jaw. As you can see, it's almost got like a jet chin going on, of course. So I really want to talk about the species because it's a really different animal. So it represents a novel morphology in these, or morphotype among thyreophorans. So it's basically like completely out of left field. It includes, among other things, the presence of a predentary bone, which is absent, or cartilage in later by other basal thyreophorans. It has large low osteoderms and a bipedal stance similar to Scelidosaurus. And it was considered to be a small animal, about 1.5 meters long, or about just under 5 feet, and weighed about 4.5 to 7 kilograms in weight, based on femoral circumference. And while the holotype do not resemble a juvenile individual, it was likely not fully grown or may have not been sexually mature. So it may have got a little bit bigger, probably no more than a couple meters. It wouldn't have been a big animal, wouldn't have been very huge. But that's what also makes it kind of weird. So due to its combination of features seen in basal ornithischians, basal thyreophorans, and ankylosaurs, the phylogenetic analysis actually placed it as a basal thyreophoran, just out of the clade Europoda, so just before the stegosaurs and the ankylosaurs. So they're the closest living relatives to them. And Regina and colleagues suggested in 2022 that Jacopil represented a member of a previously unknown clade of thyreophorans. So it's a very interesting, basically an animal that kind of throws a spanner in the works. This clade would have diverged from the rest of the thyreophorans in kind of the late Jurassic, the Cimmerian, which is in the lower Jurassic. Its discovery in the Cretaceous implies a ghost lineage. So a ghost lineage is when often you will find something and it goes missing in the fossil record, then you find it again, so there's kind of a missing thing. A great example is the coelacanth. We thought they were extinct for 66 million years, and then we found one in the bottom of the ocean. So that's a great example of a ghost lineage. This is another great example. So there was believed these 90 million years of evolution between Scelidosaurus and its relatives, and then Jacopil. So there's about 90 or so million years that were like, what evolved there? What kind of relatives of Jacopil live there? So yeah, that's a very interesting thought as well. So the status of Jacopil as a thyreophoran has actually been kind of disputed by some researchers. A study actually looking at suggested it may have It also noted that it possessed dermal armor, which is a feature not in other thyreophorans. And the premaxive Jacopeal has no teeth, which is a feature not seen in any other thyreophorans. And the shape of the dentary is actually more similar to basal Neroceratopsians. So that could actually make it a great example of convergent evolution, evolving these osteoderms. Additionally, though, the teeth Jacopeal are morphologically distinct from any other thyreophoran, and even suggest that may be more related to macrocephalians, which includes pachycephalosaurs and ceratopsians, or a member of a yet-to-be-known lineage of non-thyreophoran ornithischians. So it's a very interesting... It's an animal that kind of throws a spanner in the works, so we don't really understand how it is related, because it's just so different and so distinct from most other ornithischians. But in the latest analyses, Forneshka and colleagues recovered Jacopeal as a sister taxon to Uropoda, or as the basalmost member of Ankylosaurs. They argued that Jacopeal is likely not a ceratopsian or metacephalian, since that would require another 16 additional steps. So, Occam's razor is the simplest explanation, is most likely the real one. So it's either a very basal ancestor to the thyreophorans, or it's the basalmost ankylosaur. So, it doesn't change that much in the family tree, to be honest. However, a position within Panankylosauria only has 4 additional steps. As such, the author suggests that this possibility should not be disregarded, even though not the most parsimonious position for this taxon. So, likely, could either be basal to both thyreophorans, or potentially the most basal ankylosaur. So that's kind of what they suggest. But in terms of paleobiology, looking at its snout, they actually suggested it did not use its teeth or jaws to share leaves, but likely possessed tough plant material versus mastication. So it had high wear in its teeth, so it likely ate rough plants. And in terms of its paleo environment, so it lived in a very rich formation. Lived with some actually pretty famous characters. So the Calderos Formation is interpreted as an ancient desert with some oases in it, and fossils represent a Middle Cretaceous ecosystem in the western remnants of Gondwana. So other animals found in this formation include the Rhynchocephalians, Tika, and Prosphosphenodon. So those are distinct relatives of the Tuatara. The snake Najash, the mammal Coperodeltacurtus, and theropods Bueroraptor, Ixonosaurus, Anashari, and Giganotosaurus. So it did live with Giganotosaurus. So this little guy would likely be the potential snack for young Giganotosaurus. And lived with sauropods, Andiosaurus, and Lemosaurus. So very rich formation, very interesting. So this little guy lives with, Giganotosaurus. And it's really, really cool. I really love this little mod. He did a great job. NetRaptor, just knocked it out of the park with this one. I really do like this little mod. And nice to see a species that's just so different. Most of them are very similar to other species in the game. This one really is a different animal. But yeah, good one on that, NetRaptor. We're not done with you yet, though. So next up, we've got a sauropod from you. This is Jukenulong. This is another really cool one by NetRaptor. Look, big and gigantic. It's quite nice to go from a very small animal to a very large one. So this is Chujiangulong, which is a herbivorous Mamenchisaurid sauropod, which is known from the Shuning Formation in China, and is debated from either being late Jurassic to early Cretaceous. And it contains a single species, Quinjulong gurkor, or Gurku. I'm not sure how you pronounce that, to be honest. Known from partial skeleton that includes cranial bones, most of the neck and tail, and other elements. So the vertebrae of this species was found in the early 1990s by farmer Chai Changming in the Hebai village in Sichuan, in his backyard, and then work on an nearby construction site actually uncovered quite a rich quarry in there as well. And they kind of took out the specimen as well. And in 2015, the type species Juinulong gurkor was described by Jinglida Teshuda Mashida, Li Daquing, Ye Yong, Toru Sakia, and a few other paleontologists, and Philip John Curry, the only English person there. And the generic name basically means Ukuzhang dragon, and Jukol means nutshell, as referred to the Chinese social network, the scientific social network, which is interesting as well. So in terms of its holotype, was found in the Shuning Formation. The age of this formation is debated, with various different dating methods and methods suggesting either a late Jurassic or early Cretaceous origin. So this could potentially be quite a late surviving Mamenchusaurid, which is interesting as well. And the specimen itself is a partial skeleton that includes the rear of the skull, the partial right lower jaw, a complete series of 17 neck vertebrae, the first 6 back vertebrae, ribs, a portable 10th tail vertebrae, a series of 28 red tail vertebrae, chevrons, pubic bones, and the phalanges as well. And it likely represents a juvenile individual, which is quite large, but is considered immature, so it could potentially got bigger. So it was quite a big animal. The holotype itself was estimated to be about 15 meters long, so that's still quite a large animal, and again, still growing, and had a long neck. Describing authors found several distinct traits among it that kind of distinguish it from other Mamenchusaurids. So these diagnostic traits, these are things that are little different things in the fossil that suggest, oh, this is a different species. That's why it's sometimes when you find just one bone of an animal, you can't name it as a different thing because it's got no diagnostic traits, so you can't compare it to something and be like, okay, that's different. So that's how we define, or how we find a new species, by comparing. So these ones that had a few different diagnostic features, which I'm not going to go too into. But in terms of its systematics, it was placed in the family Mamenchusauridae, which related to Mamenchusaurus and its relatives, in a relatively basal position, but above Omanosaurus fuensis in the evolutionary tree. Sorry about that. So it actually is quite basal in the tree, but lived quite late. So that's like a less extreme example of Jack Peel. But yeah, really, really cool. Love how this came out. I love the reds on it. The reds look really, really nice. I love the pattern. And you're going to gotta love the face as well. Look at that. Look at that goofy face. And proper feet. Yay! Always like, so it's pointing out the proper feet. So yeah, we're going to let you run off and do your thing. So next up, we're going to go into the lagoon. This one was done by Viral Cyclops. We have got Photos Proto Spherida. You say that? So we've got some fish to talk about, which I'm always excited to talk about. See if we can get you out in the... Why they panic like a rock coming out of the... It's a bit weird. That's right, we'll pick one that looks nice. I like this one. So these guys are very interesting. So these are a genus of swordfish-like marine fish that lived worldwide during the Cretaceous period, from the Albian to the Maastrichtian. And fossils of this taxon have mainly been found in North America and Europe, but potential specimens have been found in Asia, Africa, and Australia. Its fossils are best known from the Smoky Hill member of the Navarro Formation in Kansas. And these guys were considered actually quite a large fish. They got about 2 to 3 meters, or 6'6" to 9 feet 8 inches in length. And they would have shared the Cretaceous oceans with a lot of marine reptiles and mosasaurs and plesiosaurs, as long as fish like Sphancterus. So the name Proto-Sapphira means proto or early Protosapphira, which is the genus name for barracudas. So it's basically a giant. So it basically means before barracudas. And they initially took it, because they initially mistook it as a genus, as an early relative of Barracuda. But now it's believed they are, this is not related to the true swordfish family, but they belong to an extinct family called Pachychomyridae, which is a very interesting group of prehistoric fish that includes both filter feeding. This is actually a great example of convergent evolution. So one of the most famous members of the Pachychomyridae is Lysixes, which is a giant filter feeder, but this is obviously not a filter feeder. This has got, very convergent to a swordfish. So the Pachychomyridae were almost very great examples of convergent evolution, because we had some that were like basking sharks and whale sharks were being big and filter feeders, and these guys are like swordfish, which are swordfish, so that's a predator. So it's a great example of convergent evolution. So in terms of its history and taxonomy, there's actually quite a few species described. The type species is ferox. So in case with many fossil vertebrates during the 19th century, and it's a very confusing history. So it was first found in 1822 from chalk deposits in England by Gideon Mantell, who also discovered iguanodon. And then 1857, the first American specimen was named Protosphaera ferox by American naturalist and paleontologist Joseph Leddy, based on Mantell's English findings. So it's got a very complicated taxonomic history, but mistakenly identified to come from a dinosaur as well. So there was a tooth that came from New Jersey in the Maastrichtian, but was thought to be a dinosaur. Fossils collector Edward Drinker Cope and Marsh, they had a number of species they named, but a lot of that was potentially just erroneous. But today there are kind of two species recognized from the Nibiru chalk in the western US, Nida and Prasicona. Additional species has been named on older members, but I'm not sure how true that is. And then the species also Australo-Pachycormus hulleri, which means southern Pachycormus, was actually a close relative of this guy and was the earliest Cretaceous pachycormid in the southern hemisphere. And it seems to closely resemble that in description, so it could be a great example of convergent evolution, or most likely, I'd say, that shows they have a global distribution. So in terms of its anatomy, they resemble a lot a modern sawfish, as you can see there, though it was smaller and had a small rostrum, and somewhat less hydrodynamic, with adults possessing large blade-like teeth. And complete specimens are relatively rare, but in parts in Nibiru chalk, the Marival chalk formation in Alabama, and other geological formations, you can find full fragmentary specimens that can be quite common, and mostly teeth and rostrums as well, and fragments of the pectoral fins. Usually the portions of the skull are found separated, and this preservation bias suggests that actually this species may have had, or the skeleton of the species may have been less ossified, or more cartilage rather than bone, and would have been torn apart by scavengers as it decayed. And like most other large Cretaceous marine fauna, the pachycormidids, for the most part, went extinct during the end of the Mesozoic, so when the big rock hit the earth, and all the resemblance to the modern sawfish is all convergent evolution. That's when two lineages evolved to look similar because they do similar things. So that's a great example of that, because the pachycormidids are a very interesting group. The pachycormidids are an extinct order of fish from the Cretaceous, and there's lots of different types. As I mentioned, there's macropredator ones. There's a giant Lizithes, which is a filter feeder. So they evolved into a lot of different interesting niches as well. So yeah, very, very cool. So yeah, that is this guy done. So next up, we're going to have a look at, this is by Gushigor. We have got Stethecanthus. This one's a little bit more of a famous one, so I'm sure you guys will recognize this one. Let's see if we can find... Let's have a look at you, because you've got the nicest colours on here, I think. They look really, really nice. These are all males, I think. Alright. So this is Stethecanthus. These are an extinct genus of shark-like cartilaginous fish, come from the late Devonian and went extinct in the late Cretaceous. Not late Cretaceous, late Carboniferous. And dying out only about 298 million years ago. And have been found in Australia, Asia, Europe, and North America. So its name, it means chest, stetho, so chest, and cantholus means spine or thorn, so basically it means chest thorn. And the name refers to its very interesting looking anvil-shaped first dorsal fin and spines that are displayed by mature males of the genus. So only the males have this, really. So I'm not really given a species description, of course, for this one, but there is quite a few different species. So they had different sizes depending on species. So some species got to about 1.5 meters, while some species like Productus got to 3 meters. So they did get quite big. And in many respects, they have a shark-like appearance. So, they've got the long body, very shark-like. But what sets them apart is their unusually shaped dorsal fin, which looks like an ironing board or a anvil. Small spikes as well, as you can see the little spikes on the top there as well. They cover its chest as well as its head, and they are believed to have potentially played a role in mating rituals, aiding in clamping to the belly of larger marine animals, or being used to frighten predators and make them harder to eat. And like other members of Stethacanthidae, they had unique pelvic girdles, single-crowned non-growing scales, a pectoral fin comprised of metaphylogium, and a whip-like appendage attached to their first dorsal fin and spine. So yeah, traits typical of their relatives as well. So these kind of spine bush complex occurs in the same site of the first dorsal fin and on other ratfish, and has a basal plate as well. So it's very interesting how that looks. So you can see these denticles on the top here as well. They kind of give it that interesting shape. And then they've got this, pectoral whip. So this is comprised of the pectoral fins are comprised of metaphylogen, which occurs in modern-day sharks, but they have this long structure called the fin whip. And the fin whip contains at least 22 axial cartilages and extends past the pelvic fins. So that kind of an interesting thing they have. We don't know what the use of these whips were, but potentially in mating. That seems to be what they use, when they can't understand it. In terms of its teeth and denticles, they had wheel shapes, and the platyquadrate was scalloped, with 67 recesses allowing for the tooth families. So individual teeth were widely separated from each other. So this suggests that they may have potentially had, don't really have you look at the teeth in there. Would have been potentially eating, more hard-shelled things, or potentially, just had wider space teeth. We do know it was a carnivore, though, so that makes sense. Would have eaten, like, brachiopods and small fish and stuff like that. Until its pelvic girdle. Its pelvic girdle had sheets of prismatic cartilage, with each having a subtriangular rounded plate. And the broadening of the pelvic girdle actually helped as well to accommodate the increased number of radicals that is characteristic of this group. And the males had claspers that were club-shaped on the distal end, or the back end, and composed of non-prismatic globular calcified cartilage. And the caudal fin is also very interesting. There is some variety of caudal fins among the different species, with some being low in angle and some having higher ones. So you can see this is an example of a higher one. In terms of its paleobiology, Stethacanthes was believed, as I mentioned, to be a carnivore, eating small fish, brachiopods, and ossicles as well. And additionally, as the spine brush complex was a large structure, it seems that it would have provided a drag force during fast locomotion. So it's believed that the shark would have been quite a slow-moving shark. And the fins are also smaller than other shark species of the same size. And their teeth are also relatively small compared to other small Paleozoic sharks. That suggests they may have been a bottom dweller, so they may have been more, benthic, kind of hanging around at the bottom. And considering that most of them have come from Bear Gulch limestone or Montana, that suggests that they weren't. There was not only a breeding ground for other sharks, but also Stethacanthes, and suggesting they were also migratory, so they may have been a migratory species. In terms of its history, though, there is several species that have been described. I'm not sure how many actually stand the test of this day. So there's 1, 2, 3, 4, 5, 6, 7, 8 species. And several species were discovered in like 1800s based on spines, upon isolated spines, and that confused a lot of paleontologists, so they had to go through and kind of fix that as well. Meanwhile, the first associated skeletons were actually found in the Mississippian of Montana and the Devonian and Mississippian of Ohio, and they remained undescribed for nearly a century. But since complete fossils are extremely rare, these are kind of vague. And it was not until 1974 that the family Stethacanthidae was defined, because Stethacanthes differed so greatly from other lasmobranchs at the time. So we do have a lot, but we've never been found from China. They've been found from Russia, Scotland, as well in Western Australia, so they did have quite a wide range. And in terms of its relatives, it's interesting that there was the first recorded mass, so these kind of large, spines and bush complexes are interesting because it's the first example of globular calcified cartilage in chondrichthyans, which is the group that includes sharks and rays. This raises a lot of really weird questions about shark evolution. But taxonomic relationships with these guys are kind of hard to define, as there's much variability in characteristics. Chondrichthyes is quite a monophyletic group that is defined by the endoskeletal tesserae and internal fertilization. That's how they're kind of defined. So we don't know exactly where they fit in that group. We know they're the Chondrichthyans, and actually more recently they've been suggested to be part of Homocephaly, so they actually, Stethocyanthus may have actually been more closely related to chimeras than modern chimeras and sharks. So we don't know exactly where it is, but we know that they're a Chondrichthyan. Pretty much that's as low as we'll go in the group Stylothorformes. So very, very interesting. You know, they may be not a shark, but a little bit more like chimeras. So very interesting revelation in that regard. But yeah, we're going to let them swim off, do their thing. But next up, we have got some more animals by Netraptor. I can love Netraptor. Next up, we've got Ceratopsuchops. So this is actually a more recent one, so let's have a look at this guy. Let's have a look at you. You look quite nice there, actually. So this is Ceratopsuchops, which means horned crocodile face. These guys are a genus of Spinosaurid. They're known from the early Cretaceous of the Wessex Formation in Britain, and its type specimen is C. infundios, which is known from just skull fragments. So the hard type of this taxon basically includes premaxillary bone, an incomplete brain case, and a couple other little bits here and there, a bit of the frontal as well. And they're recovered from the Triton chinlay from the Wessex Formation. In 2021, it was named and described by a team of paleontologists, including Chris Barker and Darren Naish, David Hone, and them. And its specific name means hell heron. So Inferdios means hell heron, as a reference to its potential ecology. Is that actually moving? Yeah, that is moving. Saw it, noticed it very slowly. I hate it when it does that. Anyway, we'll carry on. In terms of classification, it was initially kind of found to be a member within the Baryonychines, an sister taxon to the closely related Rhipavenator, which was actually described with. So there was a paper describing the two genera. And in turn, actually is more closely related to things like Suchomimus rather than Baryonyx. But in 2023, they actually created a group. Sereno and colleagues created a very small group, kind of a single taxonomic unit called the Ceratopsini, which includes Ceratopsuchops, Rhipavenator, and Suchomimus, kind of in their small group. The reason for the different features between the two taxon could be attributed to a variation. So it's potentially they could be both the same species. But yeah, I'm not going to get into that too much. But yeah, in terms of paleobiology, they actually did a lot of study because, as I mentioned, that is a perfect brain case. So a 2023 study by Barker and colleagues looked at the CT scans of both Ceratopsuchops and Baryonyx and found the brain anatomy of these Baryonychines was similar to other non-maniriptorian theropods. So they would have had their sense of smell and hearing were unexceptional, and gaze stabilization was less developed than those of Spinosaurians. So these adaptations were probably comparable to those of other large-bodied, terrestrial theropods. And this suggests that the transition from terrestrial hypercarnivores to semi-aquatic generalists during their evolution did not require actually substantial modifications to their brain and sensory systems. So they were basically already ready to go. It's probably the best way to put it. And this means that Spinosaurids were either pre-adapted for detection and capturing of aquatic prey, or their transition to semi-aquatic lifestyles only required modifications to the bones associated with the mouth. And their reptile encephalization quadrant implies that the cognitive capacity and behavioral sophistication of Baryonychines did not deviate much from other theropods. So they didn't seem to be, brain boxes compared to other. They would have been about as smart as other theropods. But yeah, in terms of the environment this guy would have lived in, we lived in the Wessex Formation, which was a very dry Mediterranean habitat, and lots of riparian zoos, and would have fed on a lot of small, medium-sized animals. But lived with a lot of famous animals, things such as Rhipavenator, Neovenator, Iguanodon, Hypsilophodon, sauropods as well, and Polycanthus. So very rich habitat. And stated in 2021, these two species actually provide the idea potentially for ecological separations. So there would have been 3 different Spinosaurs living in the West Formation, so there may have been some ecological division. Maybe one would have been living in more deeper water, one would have been in more, more terrestrial. It's kind of a great gradient, so there would have been a lot of different niche partitioning there. Though they were likely also separated from time, so potentially, the one may have been older, one may have been younger, so they may not have actually all lived together. And it's generally thought that large predators occur with small taxonomic diversity in any area due to ecological demands. But many areas, Mesozoic assemblages have two or more sympatric theropods as well. And this appears to be the case for Spinosaurus as well. So it seems like high diversity suggests they may have had different niches that allowed the coexistence of these very similar animals. Potentially may have been niche partitioning could have been in time, so one could hunt in the day, one could hunt at night, or maybe between habitats, or maybe there could have been differences in climate, so they would have had preferred wetter or drier habitats. There's a lot of ways that could have niche partitioned, like today, and also I think the example as well, we usually have one or two big carnivores, because in today we live in a very impoverished ecosystem. So you think about like North America in the last ice age, you would have had lots of large predators. You would have had American lions, you would have had saber-toothed cats, dire wolves, and then you have other animals. There's lots of large animals in the ecosystem, plus all the modern ones like jaguars and red wolves and all of them. So there would have been quite a rich ecosystem. We just I think they just compare too much a little bit to modern ecosystems, which are for the most part greatly impacted by humans. So that might be a little bit of a unfair comparison. But yeah, really, really cool. Ceratopsicops. Another great one to talk about. But next up, we've got another one by Netraptor as well. We have got Yangchingosaurus. So let's have a look at this guy. And I gotta go turn the park off. Nah, we'll worry about that now. Let's have a look at you. That's the one I want to look at. There we go. Oh, we'll have a look at you. You've got a nice position going on there. Look at you. Very, very cool. So this is Yangchingosaurus. So Yangchingosaurus is an extinct genus of metriacanthid theropod, which comes from China from the middle to late Jurassic, and was similar in size to its North American relative Allosaurus. So Yangchingosaurus hails from the Upper Saximo Formation and was one of the largest predators in that ecosystem. And that included, things like sauropods, like Bemidjisaurus and Ameiasaurus, Chingalingosaurus, Chunkingosaurus, and Chijungosaurus, which are all stegosaurs. It was named after the area it was discovered, Yongcheng in China. So this was first discovered, as I mentioned, the first species is Yangchingosaurus sanjuensis, and was found on the basis and was named by Dong et al. In 1978, based on a complete skull and skeleton, which was found in the Saximo Formation near Yongchang and the Yongchang district of Sichuan. It dates to about the Oxfordian, so like Jurassic, between 161 and 157 million years ago, and was discovered in June 1977 by construction workers when they were working on the Shangzhou Reservoir Dam. A second species was also described in 1983 by Dong et al., based on another complete skull and skeleton as well. And the differences are primarily on the basis of size, and Magnus had additional fenestrae. But for the most part, it is considered they would have been the same thing, because, that could have been either differences between individuals, difference between growth stages, or just, variations, so they were lumped in the same species. However, the parents' differences of cranial morphologies could be explained by comparing different positions within the column. And hence the holotype of the two species were considered identical, so they kind of lumped them together. And Gregorius Paul considered this, a Yangchingosaurus, a Metriacanthosaurus, to be the same thing, but this is not supported. So there are additional specimens and kind of species. I'm not going to go too much into that, but a lot of them have been lumped into each other. So there's kind of two question ones, but the main species that has kind of stood the test of time is Yangchingosaurus shangzhouensis, for the most part. But yeah, in terms of its description, it was quite a big animal, about 8 meters long, had a skull 82 centimeters, and the largest specimen of Manus was even larger, may have got to 10 meters long and weighed as much as 3 tons. And suggests the same species would have been about 11 meters and 3 tons, and it had bony ridges on its nose as well, very similar to things like Ceratosaurus and Tamiya. So this would have been a large animal in the ecosystem. It's from Metriacanthosauridae, so it would have been related to things like Metriacanthosaurus. Would have been a large, powerful meat eater, walked on two legs, quite muscular legs as well, short arms, strong short neck, and big powerful jaws, and a long massive tail as well. So this guy was built for eating large animals. So it was kind of like the Allosaurus of China at the time. But in terms of its phylogenetic relatives, it is found to be the basalmost known Metriacanthosaurid and the only non-Metriacanthosaurine Metriacanthosaurid. So that's a big word there. But more recently as well, there's been some other 2019 that suggested that it was actually not that closely related, but they seem to have been. There was one description of Arulukush was found to be its own species. So yeah, Yangtringosaurus is a really basal member of the Metriacanthosauridae, is a basal member of Ankylosauria, and this would have been related to things like Synraptor, Metriacanthosaurus, and Sinotyrannus. And then, we'd have had Allosauria, and then come in there. So yeah, really basal member, but also very interesting, very big animal. So yeah, really, really cool. Let you run off and do your thing. So last but certainly not least, we have got by Trippy13, we have got Mapusaurus. Look at that's a Mapusaurus if I ever saw one. It's a very, very cool animal, and of course it has the bug. You gotta have that. They'll have a look at you. I like how you're standing. So this is Mapusaurus. So Mapusaurus, which means earth lizard. These are a genus of giant Carcharodontosaurid carnosaurian dinosaur that lived in Argentina during the Turian stage of the late Cretaceous. This guy was originally excavated between 1997 and 2001 by the Argentinian-Canadian Dinosaur Project from an exposure in the Huincal Formation that came from the late Cenomanian to the Turian. And was ascribed by paleontologists Phil Curry and Rafaldo Correa in 2006. The name Mapusaurus describes from the Mapuche word mapu, which means the land or of the earth, and the Greek saurus, which means lizard. So Mapusaurus rosea is also the specific name refers to the rose-colored rocks where it was found in. And for Rose Litwin, who sponsored the expeditions that, kind of found the fossils. So the designated holotype for the genus and type species was isolated right nasal, and 12 paratypes have been described based on additional skeletal elements, and taken together, these individuals recovered from the Mapusaurus bone bed represent most of the skeletons. So we do have a pretty good idea of what this guy looked like, and a lot of different specimens too, which is very, very cool. So these guys were very large theropods, so they were slightly smaller than its close relative Giganotosaurus, but probably marginally. So the larger specimens of Mapusaurus got to about 10 to 12 meters, or between 33 to 41 feet, and weighed between 3 to 6 metric tons. It has been determined that it was diagnosed by anthropomorphies, or unique traits that Giganotosaurus does not have. So it really is not too different, but it has a second opening in the middle quadrate, which is the main way you can tell them apart. But they're very similar looking species. A biomechanical model of Tyrannosaurus suggests that these guys could have 11 miles per hour. So these guys wouldn't likely have been big runners, but they would have been able to, walk at solid speeds. But yeah, there's some very interesting things we know about Mapusaurus. So, in terms of paleobiology, the bone bed that we mentioned contains at least 7, but potentially up to 9 individuals of various growth stages. So, they postulated or speculated this may represent a long-term, potentially a coincidental accumulation of carcasses or a predator trap, or it may provide some clues on Mapusaurus behavior. So there are lots of different theropod bone beds found. There's ones with Deinonychus and Utahraptor, and those of Allosaurus in the Cleveland Lloyd Dinosaur Quarry of Utah, but also Tyrannosaurs like Tetraphonius, Albertosaurus, and Spinosaurus. There's a lot of bone beds. There's also the suggestion it may have been a social animal, living kind of more socially, which is, I think, a fair conclusion to make. But quite interesting as well. Paleontologists Rafaldo Correa and looked at Cherida's article, um, released a press conference earlier. Suggestions of this may actually be that Mapusaurus, like Giganotosaurus, may have actually hunted in groups to hunt large sauropods like Argentinosaurus. And if this would be the first substantial evidence of gregarious behavior in large theropods other than Tyrannosaurus rex, although whether they hunted in packs, like wolves or lions, or just simply mobbed the animal, like a Komodo dragon would, is unknown. So we know that potentially they could have hunted together, but whether that was an organized hunt or potentially they just all happened to be in the same area and they're like, oh, let's work together to take down this big thing, we really don't know. The authors interpreted the dispositional environment of the Huinkel Formation as well as a freshwater paleochannel. It's laid down by seasonal or ephemeral streams in a region that was arid or semi-arid. The bone bed was especially interesting in light of the overall scarcity of fossil bones within the Huinkel Formation. In an ontogenetic study as well by a colleague in 2014, found that Mapusaurus displayed heterochrony, which is actually a condition in evolution that animal retains an ancestral characteristic during one stage of their life, but lose it as they develop. And the maxillary fenestrae kind of is present in young individuals, but disappears as they get older. So that's an example of that. So in terms of its classification, it is believed to be Carcharodontosaurid, and looking at its relationships, it seems to be closer with Giganotosaurus, which makes sense. Seems to be the sister species of Giganotosaurus, and its relatives as well. And in 2022, with the description of Meraxes, it is believed to be, so Meraxes is kind of the most basal Giganotosaurini, and then you have Tyrannotitan, and then Giganotosaurus and Mapusaurus are considered sister species. And that kind of holds up pretty good as well, which is interesting as well. But there has been some changes in taxonomy there. So, as previously mentioned, the Huinkel Formation was thought to be an arid environment or seasonal streams. The age of this formation is between 97 and 93 million years ago. And the dinosaur record is sparse here, but what's quite funny as well, we always see in, Chased by Dinosaurs, Giganotosaurus hunting Argentinosaurus, but actually they did not live together, they were separated by time. So, Giganotosaurus is geographically older than Mapusaurus. So Mapusaurus was the one that hunting Argentinosaurus. They would have lived in that area together. They would have lived in the same time. So Mapusaurus would have potentially been hunting Argentinosaurus, which is the largest dinosaur known, potentially one of the largest sauropods. Also, some sauropods such as Tronosaurus, Castellosauria, and Chronoganosaurus, some other smaller species of sauropod. There were other species of giant Carcharodontosaurids, such as Megaraxes and Taravenator, and they were found in the same formation, but in older rocks, so they likely did not evolve or live together, so likely they would have potentially split off doing their own thing, but they likely did not live in the same time. They lived in the same formation, same place, but not the same time. Because you've got to think about it as well, because even though you think, all these different dinosaurs, but they may not have lived in the same time as each other. Because it's layered, and they were found in older rocks, and they were probably not co-evils, co-live together. And the Albertosaurids, such as Scorpiovenator and Zerkella, also lived in the region. So yeah, they would have been quite a rich little ecosystem there. In terms of fossilized pollen, it actually indicates there was quite a variety of plants living in the Huinkel Formation, including hornworts, liverworts, ferns, gymnosperms and angiosperms are flowering plants in lots of different formations as well. And in terms of non-dinosaur, it actually is one of the richest Paleogonian vertebrate associations. It includes gar and other types of freshwater fish, turtles, squamates, so things like lizards and snakes, sphenodonts, which are tuataras and their ancestors, crocodilians, and quite a wide variety of dinosaurs. And vertebrates are more commonly found in the lower and therefore older parts of the formation. So this is a little bit younger. So yeah, not quite as well known. So this is, let's say, 97 to 93 million years ago. So yeah, really, really cool that we got Mapusaurus, another cool animal. Definitely a big fan. So yeah, that's a great one done by Trippy. And everyone today did a really good job. NetRaptor really knocked it out of the park. A lot of those really cool little guys. Gushy Gore and Viral Cyclops, you all did a great job. NetRaptor, of course, got to thank you again. And Trippy, thank you for that, Mapusaurus. So, yeah, I think this is a good place to end the video. I'm not going to finish these series just yet. There's a couple mods I'd really like to cover when I get the chance. So there may be a couple more parts coming, depending on how modding goes. You know, I don't tell people to mod these things. I only just cover them. So, you know, a lot of people do in their free time, so I'm not going to tell them. If they want to move on to other things, they are perfectly allowed to. So, yeah, I really, really, really hope you guys have enjoyed this video. Hope you guys like and subscribe. Always remember to hit the little bell icon to get notified of anything. So yeah, if you guys enjoyed this video, hope you guys like and subscribe, and bye-bye.